G'day. If you've been watching the videos prior to this one, you'll know I've been messing around trying to get some tools balanced in the turret to do a particular job. And this was the job. It was basically just spot, drill and part off. Not very complex, but it needed to be done in the turret. And when I set up the turret to do the job, I got a turret failure. It would do this. The tool would go up to the stop for the material, pull the stop out, then the machine the head would retract and go back a fair way because there's a big drill in there, and it would stop there. The spindle wouldn't start. Now, I did this today to prove that it was not working, but apparently today it is. So I've moved on to another job because I didn't know the turret would be working. It was failing the other day. Now that material was scrap that I've got from some years ago to make these parts for the new job. That was a 4-jaw chuck. I just stuck it in so I had something in the chuck to see how the tools were situated when they were moving around to do the job. There's the boring bar. It doesn't have much more room to retract from the material. You can see it's on 3.17 there. Well, that's only 3 millimeters away from home. The parting tool looks as though it'll work okay, so that setup of tools should be quite workable. Won't be using those jaws. They're jaws I've been using for another job, just soft jaws. Just checking there that the chuck jaws are the correct ones for this chuck, as I have a couple. There's an Arbor stop in the spindle. That will be used to push the material up to so as I get a constant length. Just checking there that the chuck is correct on the spindle in the right place, and here I'm just going around putting the chuck jaws in the right slot. They're numbered 1, 2, 3 and they go in the appropriate slots. There you can see the material stop is working. The stock just goes right up to it. That's the parting tool I'll be using, and yes, that damaged insert, I'll put a new one in there. These are the parts. They're only 3.5 diameter. But that scrap hex, it won't matter. I've had it for 5 years sitting around, so I'll just use that. Here you can see I did a drawing to show the effect of the tool nose radius on the parts. It's quite big. 0.4 radius is a large radius when you're looking at such small parts. Here we'll go into the software and look at the simulation. Make it a bit bigger. Now I can't tell the software to use a left-handed boring bar, so we're just using a right-handed tool, which is all the boring bar is doing anyway. So there we go, around the profile, creating tiny chamfers. These parts are to go into clock plates so that they can be re-bushed and have new bores cut for the pinions of the gear wheels. There we're cutting the second one around the profile. Now I have to admit, I cut a couple of these with the camera not running, and the result was absolutely horrible. The parting tool was really struggling to work at all, and this is why. It's so high, I have no idea why it's gone high. Possibly I've got a shot pin damaged in the turret. So we'll see how we go. I'll fix it and make some parts in the next video. Thank you for watching.